Alrighty, we're going to dive in. We're not going to cover all of Module 8 at this time. We have a few things we need to get in before MCA testing, and then we'll probably revisit this in April or May after we get done with our standardized tests. So we're going to do a little bit in Mod 8. And so what I need you to do is open up your book to page 237 and follow along with me. Alrighty. So we're going to get into talking about similar shapes and scale drawings today. And so our essential question here is, how can we use scale drawings to solve real world problems? And if you go into architecture or landscaping or even just designing toys and things, doll houses, I'm thinking like G.I. Joe and just tons of toys, little race cars and that kind of stuff. We're using scale and scale models all the time. They're everywhere we look, okay? So let's take a look at this first example when it talks about finding dimensions. It says we have a blueprint, and what a blueprint is a drawing of something that is going to turn into real life. So whether it's of a house or, like I said, landscaping and that sort of thing, you'll see them a lot. Frankly, what we see on HGTV today, they have all that fancy three-dimensional stuff that they use and not just a plain blueprint like we've used for so many years before that. So technology is making it pretty cool. But we have a blueprint, which is just a drawing. Pete's blueprint shows a layout of a house, and every 4 inches in the blueprint represents 3 feet of the actual house. One of the walls in the blueprint is 24 inches long. That'd be this one right here. And they're asking you, what is the length of the actual wall? Okay, so it says every 4 inches, look at this table. Every 4 inches represents 3 feet. So if I have 4, that's 3. If I add another 4 inches to 8, you get 6. Going up again by 12 and 16 and 20 and 24, go ahead and write in the values to complete that table. You can pause the video for a second to get that written down, okay? Alrighty, here's where we end up here. And what kind of patterns do you start to notice here when you're looking at this table? I noticed that this one tends to increase every single time by 4, while this one here ends up increasing each time by 3. Cool. It says in Pete's blueprint, the length of a sidewall is 16 inches. Find the actual length of that wall. All right, well, as we looked at our table, a 16 inches on the blueprint would be 12 feet. The back wall is 33 feet long. What's the length of the back wall in the blueprint? Aha. Okay, my table doesn't go up that far because this is the feet. That's the bottom row. We have to figure out here, when is this equal to 33 feet? And figure out what is this value of my inches. Now, the nice part is this kind of makes a nice little situation mathematically that we call a proportion, because I could take my initial scale here, 4 inches to 3 feet, and that equals, I don't know how many inches, but I get 33 feet. When you have 2 ratios, or in this case, since I've written my ratios as fractions, when you have 2 fractions that are equal to each other, that forms a proportion. So 4 inches is to 3 feet. That has to equal this over 33. Now, there are a lot of ways to go about solving this, all right? When I look at this, when I see 3, and over here I have 33, I would simply probably say, gosh, I can see already that to get from 3 to 33, I just need to multiply this guy by 11, okay? Which means if I multiply it by 11 in the denominator to get there, you could do the same thing up here to get this one, and you should get 44 inches. You could also build out the table and keep going, 21, 24, 27, 30, and get to 33, which means then this would build this way, 28, going up by 4s, 32, 36, 40, bingo, 44. Okay? If we find a faster way that's more efficient than to keep building the table, this is kind of nice. Now it says, how do you know my answer is reasonable? Well, as I start here, I can basically kind of see that it should be increasing. I notice that that to get from 3 feet, I multiplied by 11. And so similarly, you would do the same thing to that numerator. So then take 4 inches, and I know it should get much bigger because I built the table. Take 4 inches, and you can also multiply that by 11. And that's why, yeah, that makes sense. It should be a lot bigger, okay? That's the way the pattern is growing. All right, turn the page. Here's where we're getting some definitions then. First of all, a scale drawing is a proportional two-dimensional drawing of an object. Scale drawings can represent objects that are either smaller or larger than the real thing. So for example, usually when we look at a blueprint or a toy, that's something smaller. I don't know if you're going to end up doing this in science, but sometimes we build like a model of a cell. Now a cell is microscopic, super tiny. So then we would make our model much larger so that it's easier to see the parts and components. All right. The scale is a ratio, okay, comparing two numbers between two sets of measurements. It shows how a dimension in a scale drawing is related to the actual or real object. Scales are usually shown as two numbers separated by a colon, like this, 1 to 20, or like this, 1 centimeter to 1 meter, okay? They can be shown in the same or different units, okay? So let's just take a look at this one right here. In fact, online, Professor Berger, I think, does his real-world video, an example, math on the spot video with this particular painting. So let's say this is the scale drawing, and they're going to blow this up to be a huge mural. Right now, they know that the width of this picture is 11 inches. The length is 28 inches, okay? Now, the scale that they're using is 2 inches is going to represent 3 feet in the real one, okay? 2 inches to 3 feet. I'm going to write my scale as a fraction. Now, I have different units, inches to feet, and that's okay. You don't have to convert 3 feet into 36 inches. You certainly can, okay? And if you do that, then you don't even have to use the labels anymore. But here, I'm just going to leave it this way, and knowing that I'm always going to put my inches on top, feet on the bottom. All right, if I want to find, they're asking you what's the area of the real wall. So we've got to find the width, we've got to find the length, or in other words, the base and the height, and then compute the area after that. So let's take a look here. If I want to find my width here of the rectangle, also known as the height, and I'm going to use, you know what, I'm going to use W here, or down here, because I don't know what it's going to be in the real one, but I know here it's 11 inches, okay? Now, to get from 2 to 11, I don't know, can you figure that out? If I tried 5, 2 times 5 gives me 10. That's not quite it, okay? So here's what you're up here in your head spinning. I'm thinking 2 times some number has to equal 11. Okay, we're trying to figure out what that is, because then I can use that multiplier here. I'm going to call it K. This is like your magic, I shouldn't call it magic, but this is this proportional ratio, all right, that we're looking for, the constant that you multiply by. So if I want to figure out what K is, get a calculator if you need it. Really, let's just divide this by 2, divide this by 2. 11 divided by 2, I believe, is 5.5. So that's going to be this constant that I multiply by to get from 2 to 11. Do the same thing in the denominator. multiply by 5.5, 5 5/10, and see what you come up with for the width. Grab your calculator and do it. What'd you get? Did you get 16.5? So the width in real life is going to be 16.5 feet. Holy cow. If you think about our ceilings at school, ours are about 9 or 10 feet. So this is big. All right. Okay. Now we've got to do another one to find the length, or sometimes we call that the base, all right, of this rectangle. In my drawing, it's 28 inches. So I'm going to use my same scale, and I'm going to say 2 inches to 3 feet. That is going to equal, I have 28 inches in my scale model or my drawing. What is this in real feet? Now, if you can use X. If you'd rather use L, because then you know it's the length, you can do that. Now, this time it's a different multiplier. Let's take a look here. To get from 2 to 28, figure out what am I multiplying 2 by to get to 28. Either do it in your head or go ahead and divide these two to figure it out. I get 14. 2 times 14. So down here, take 3 times 14. Boop, and go there. You should get 42 feet. Ta-da! All right, so my width was 16.5. This is 42. If I'm asking you to calculate area, you're going to take base times height, or length times width. And that's what they did right here in step number 4. 16.5 times 42 gives you 693 square feet for the area. All right, so this is what we're doing each time. Okay, I'm going to skip over this one right now. All right, so let's take a look at number 5. Okay, I want you to look at this one with me. Find the length and width of the actual room shown in the scale drawing, then find the actual area. Oh, okay. 6.5 by 5. Here is your scale. 3 inches to 8 feet. You have to do 2 separate parts here. Okay, I'm going to come over here. 3 inches is to 8 feet. Let's find what the width of the real thing, what is this, a room? 5 inches is how many feet? So this is going to be the width of my room in real feet. Okay, how do I get from 3 to 5? How do you figure that out? 3 times what equals 5? Grab your calculator. Okay, I'm asking you, 3 times some number k gives you 5. Divide both sides by 3. You get a fraction 5/3. Don't. Thirds makes this long repeating decimal, okay? 5/3 is like 1 2/3. It's like 1.6666, and then it rounds it at the end. Leave it as 5/3. Multiply by 5/3, okay? Good. Do the same thing down here. So I need you to take 8 times 5/3. What you should get for the width is 40/3, okay? Or that ends up being what, like 13 1/3? And we're in feet. Now it said go ahead and round it to the nearest tenth. So if you look on your calculator, that's about 13.3 feet. That's the width. Let's find the length. The length, go back to my scale, 3 inches is to 8 feet. On this one, as 6.5 inches is to, I don't know how many feet the length is. Hold your horses. You got to use a different multiplier this time. How do I get from 3 to 6.5? 3 to 6.5. Well, it's more than 2. I know that much. Grab your calculator. All right. If you take that 6.5 divided by 3, you get a nasty, nasty decimal. Okay. Don't round that sucker. In fact, turn it back into a fraction, would you? Because that's just going to make it that much easier. Okay. You get something in sixths, I believe. Okay. Go ahead and find that. Do the same thing down here and see what you come up with for your final answer. Okay? I think you're going to end up with something like 17 1/3 here, or something like what? 50, 53, I don't know. 17 1/3 or 17.3 if we round it, because it said round it to the nearest tenth. Now you're not done because you need to find the area, for goodness sakes. So now I need you to go and take 13.3 times 17.3. Grab your calculator, because no one in their right mind is going to do that. Okay. Rounding that to about the nearest tenth, you get about 230 1/10 square feet. All right, cool. Here's what I want you to work on. Look at the board in front, or look in Schoology to see what I'm assigning you, just to get going on the rest of this. All right, look in Schoology. Good luck. May the force be with you.